Okay, so today we are going to be talking about measurement. This is the second concept on that we're talking about, but you should have notes for this. This will be down a little bit farther, so make sure you have those notes and you're taking notes as we go. So, measurement. The best measurements are both accurate and precise. So what does it mean to be accurate and what does it mean to be precise? Now there is a difference here. So accuracy is the degree to which the experimental result agrees with the accepted value. So it's how close you are to the actual value, or how correct the measurement is. So that will be key here. Accuracy is how correct the measurement is. Precise or precision is the degree to which measurements agree with one another. So how close or how specific the measurement is, or how consistent multiple measurements are to each other. Now, when we talk about accuracy and precision, this has been something that I used back in high school to kind of help me, that we used in college to help me, that I've used in my previous teaching when talking about accuracy and precision. It deals with targets. Now, I recently got myself a bow, so I've been using this just with my own. But this first one, this top right one, or top left one, sorry, that one right there, with all the dots being right in the middle and really close together, that is both accurate and precise. This one right here, where they're all still close to each other, but they're not in the center, that would be precise but not accurate. Down here, again, maybe these measurements aren't really that close to each other. This is probably more about, actually, this is probably what my arrow looks like sometimes, but this is what I'm trying to get to. Again, get close to it, but be close to it every time. And it's accurate, but not precise. And then this last one, where the dots aren't close to each other, aren't close to the center, that is neither accurate nor precise at all. So with this, we have some examples. So example 1, if a student shows 85% of the material, or knows 85% of the material for the test, but scores a 70% on the test, is that measurement accurate, precise, or neither? So if they know 85% of the stuff, they should get an 85%, correct? Well, that measurement isn't precise and it is not accurate either. How about this next one? Miss Joyner's dog Millie is known to weigh 65 pounds. Millie goes to the vet and is weighed 3 times at 71 pounds, 70.5 pounds, and 71.1 pounds. Are these measurements accurate, precise, or neither? So with her saying that normally she is 65 pounds, this would actually be a precise measurement, but it's not accurate. So because they are close to each other but not close to that given value, it is precise but not accurate. Now we do have something called an average. Average is where you add up all the values and divide by the total number of values. So, example, Callie measures her flower up to be 30 centimeters tall. Jeff measures the plant to be 45 centimeters tall, and Liam measures the plant to be 36 centimeters tall. Find the plant's average height. So again, these wouldn't be very precise because that's a big range there. Maybe that's 3 different plants, but again, you add them up, so 30 plus 45 plus 36. Divide by the total number. There are 3 of them, so divide by 3. Now if you do the math here, it is going to be 113 centimeters over 3. And so then if you take 111 divided by 3, that comes out to 37 centimeters. So the 37 centimeters is that average. That 111, by the way, make sure we know that is the addition of these 3 numbers, the 30 plus 45 plus 36. And then that 37 is 111 divided by 3. Now with these, we do have something called standard units. A standard is an exact quantity that people use for comparison. For instance, if you ever want to know how they come up with like a gram or a meter, there are set lengths or set units or set items that are 1 gram. Typically, they're over in Sweden, but yeah, we use now when we're doing this though, we use the SI system. We're going to use the SI system that is different than the system we typically think of. But the SI system is a system used by scientists around the world to make measurements. So each type of measurement is or has a base unit. So for instance, grams, meters, um, seconds, those are all base units. Now prefixes are used with base units that are based on multiples of 10. So some of these units, like a kilometer, is 1,000 meters. So it's based on 10, it's 10 to the third, or 1,000 times greater. So that would be one of the base units here. So the units we're going to be talking about is length. Now length is the distance between 2 points. The unit we use is a meter, or m, and often use a meter stick or a ruler to measure this. Now with mass, it's the amount of matter in an object. I think I might have told you the wrong base unit earlier, but for that base unit we use a kilogram, not just a gram. It's a kilogram. Now this is often measured using a digital scale or a spring scale. So that's a couple different ways. Next one is with volume. Volume is the amount of space occupied by an object. Unit is the liter, or L. It's a capital L. Often measured using a graduated cylinder, or can be calculated with a geometric equation. Now I'm not going to have you guys do a geometric equation to figure this out. I will always have a graduated cylinder. Now the thing, I guess it's going to go to time first. So time is the interval between two events. So that will be the seconds, or S, often measured using a stopwatch. Now one thing with volume, I kind of wish this was before time, but it popped up after. When measuring with a graduated cylinder, always measure to the bottom of the meniscus. Meniscus is that curve there. So because the bottom of that curve is at 20 milliliters, this will be a 20 milliliter mark, not all the way up here at the top where it's at 22. So it should be at 20. We do have temperature as well. That's the amount of heat in an object. Now with SI, for SI, we use Kelvin, or capital K. There is no degrees in Kelvin, it is just Kelvin. The metric system uses Celsius. Now here you see that little degree symbol because there are degrees Celsius. The US uses Fahrenheit, or degrees F. So often you are measured using a thermometer. We will learn a more scientifically accurate definition in the future when we get there. But as for now, we're just going to go with the amount of heat in an object is the temperature. Now there are some conversions here. To get to Kelvin from Celsius, you just add 273 to it, and you get the Kelvin temperature. So if I'm at 0 degrees Celsius, I am at 273 Kelvin. There are two other ways here. This is going from Celsius to Fahrenheit, or Fahrenheit to Celsius. We are going to use this a little bit. I'm not going to have you guys do a whole lot. There might be one assignment on it, and I just give you a few of the questions. But I'm not expecting you guys to know or to have this memorized. I don't have it memorized, at least for the degrees Celsius to Fahrenheit or Fahrenheit to Celsius. Normally I have to look up this equation as well. So if I have to look it up, I'm not going to have you guys memorize it either. So just make sure you guys have the equation written down. If you have that equation written down, or those 2 equations, 3 equations written down, should be easy reference later on. So in fact, there are still those different equations. So Mrs. Smith is going on vacation to Greece for her anniversary, and the weather is predicted to be 27 degrees Celsius. Mrs. Smith lives in the U.S. though and doesn't know what to pack for this weather. Help her to determine the temperature in degrees Fahrenheit so she can pack. So we need to use this bottom equation here because we are given degrees Celsius. We want to find Fahrenheit. So whatever you want to find, you want to have it by itself on one side of the equation. So that's why the degrees Fahrenheit is over here, and everything else is on the other side. If it was the other way, and we're having the question mark divided or by the degrees C, it would be this middle one. But because it's beside the degrees F, we want this bottom equation here. You're going to see that right there. So from there, we plug in, let's see, degrees C is the only thing we plug in, so 27 right there. So degrees F equals 27 times 9 divided by 5 plus 32. So you can put that into your calculator. I'm not going to expect you guys to do that on paper or anything like that. So it's 48.6 inside the parentheses because you have to do that first. Then you add 32 to that, so it's about 80.6 degrees Fahrenheit. So that means with it being 80.6 degrees Fahrenheit, she should probably be wearing shorts and t-shirt or something along those lines. And that is it. I'm not going to have you guys do this practice because again, it is something that I'm going to have you guys do here in a little bit. If you want to try it, I'll post the answers on the next video. Okay. Have a good day, guys. Maybe.